Assalamualaikum. I will be covering topic of mobile application for food donation with NGO verification and real-time tracking. These are my team members. I will explain about the introduction, problem statement, objective, scope, and finally the limitation and recommendation for our project. Food wasting is a serious global problem. According to the FAO and City Harvest, about 1.3 million tons of food are wasted every year worldwide, enough to feed almost half the world population. Here in Malaysia, SW Corps report that around 1,700 tons of food are discarded daily, and a large portion of that is still perfectly edible. The issue isn't a lack of food, it's a lack of system to connect that surplus food to the people who need it. This led to three core problems we identified. The first is there is no centralized platform. Most food donation today happen through phone call or social media, which is inconsistent and hard to scale. Second, many donors, especially small restaurant owners, simply don't know how and where to donate. So usable food goes to waste. And third, there is no real-time communication or tracking between donor, NGO, and reception, which cause delay, confuse, and miss pickup. To address this, our project has three objectives. First, design a cloud integration mobile application that connect donor, NGO, reception on a single platform. The second one is integrate at least three third-party cloud service plus one in-house web service to handle authentication, storage, location tracking, and NGO verification. And three, evaluate the complete system through the functionality testing to confirm every core module works as intended. In terms of scope, our system serves three types of user, donor, NGO, and reception. Core functionality includes register, donate posting, QR code verification at handover, live GPS tracking, in-app chat, and analytics. On the technology side, we use Flutter for the mobile apps with Firebase, Cloudinary, and the Google Map API as our three cloud service, plus a Node.js and Express in-house web service. Techniques used include location-based matching, role-based access control, and real-time data synchronization.
Now I will explain the cloud services used in our Billy Food Donation mobile application. Our application uses several cloud services to provide a secure, scalable and reliable backend system. This cloud service helps us manage user authentication, data storage, image hosting, location services and backend processing. The first cloud service is Firebase Authentication. Firebase Authentication is responsible for user registration and login. It allows users to sign up using their email and password, reset forgotten password, and securely access the application. By using Firebase Authentication, we don't need to build our own authentication system, and it provides a secure login experience for all users. Next is Cloud Firestore. Cloud Firestore is our real-time NoSQL database. It stores important application data such as user information, donation records, pickup requests, notification, and chat messages. One of its advantage is real-time synchronization, which means any change made by one user are immediately updated for other users. It also supports offline access, allowing users to continue using the app even when the internet connection is unstable. The third services is Cloudinary. Cloudinary is used to store donation image instead of saving image files directly in the database. The images are uploaded to Cloudinary. It automatically optimizes image quality and generates a secure URL, which is stored in Cloud Firestore. This improves application performance and reduces database storage. The fourth service is the Google Maps platform. Google Maps helps donors select the exact pickup location using GPS. NGOs can also view the pickup location and navigate using the interactive map. This makes the food collection process faster, more accurate, and more convenient. Finally, we have our Node.js REST API, which is hosted on Virtual Private Server or VPS. This web service handles custom backend functions that are not provided by Firebase, such as NGO verification, donation statistics, and administrative feature. It also communicates with the mobile application using RESTful APIs. Overall, this cloud works together to build an efficient cloud architecture for our application. The three main benefits are: first, it ensures secure user authentication. Second, it provides a real-time data synchronization across all the users. Third, it supports a scalable and reliable cloud infrastructure that can handle future system growth. That's all for the cloud service section. Thank you.
Next, I will explain the overall system architecture of the beelyss food donation application. The mobile application is developed using Flutter and serves as the interface for donor, NGO, and recipient. It uses the device GPS for location tracking. Firebase authentication is used for user login, while Cloud Firestore stores the application data. Uploaded images are stored in Cloudinary, and Google Maps API provide mapping and location services. Finally, a web service hosted on a VPS handles the REST API and geo-verification, analytics, and manage data using an SQL-like database. This data model represents the database structure of the beelyss food donation application. The user table stores information about donor, NGO, and recipient. The donation table records all food donation details. The pickup request table manages requests made by recipient for available donation. Finally, the donation chart table stores communication between donors and NGO. The relationship between these tables ensures data consistency and efficient management of the donation process. The web service is an internal RESTful API constructed using Node.js and Express.js and is meant to run on a VPS. There are server-side functionality provided by the web service. There are no provided directly by Firebase like Analytics for donation and NGO verification automation. HTTP requests and JSON are used to communicate between the Flutter app and the web service. The data is stored in SQL-like.
Of course, the system has some limitation. It's currently Android only. iOS support wasn't complete in this phase. It also depends fully on an internet connection since Firebase, Cloudinary, and Maps all require connectivity. Live tracking is limited to a 5 kilometer radius and geo verification is a rule-based rather than use OCR or registry lookups. Analytics are fairly basic, and our functionality testing only involves a small group of evaluators rather than a full field trial. Look ahead, we recommend expanding to iOS with Apple Sign In and an App Store release, and introducing AI features like demand forecasting, smart NGO matching, and a road optimization for pickups. Other planned improvements include an admin web dashboard, a public API, multiple language support for Bahasa Melayu and English, and eventually a full Google Play Store release with limited offline access.
In conclusion, this project successfully designed and developed a mobile food donation application that connects donors, NGO, and recipients on a single platform. The application was developed using Flutter, Firebase Authentication, Cloud Firestore, Node.js, and SQL-like. It includes important features such as food donation management, NGO verification, QR code verification, in-app messaging, donation tracking, and an analytic dashboard. Overall, the system improves communication between users, reduces food wastage, and makes the food donation process more transparent and efficient.
Now I will demonstrate the main system flow. First, I will show the donor side. Users have to register and log in, or can continue with Google Authentication. On the donor side, donor will see the dashboard and the create button. User create a food donation with detail, image, and a pickup location. The donation is then submitted and become available for NGO to review. Donor can also monitor the donation status through the application. After the donation is closed, the NGO review and manage the pickup process. For NGO sign up, they have to enter their detail and also have to upload NGO document. The NGO can accept the donation or pass it if unavailable so another NGO can take it. NGO can also chat with the donor. The NGO confirm handover using QR verification, set the pickup location, and use live tracking within the 5 km service radius. Recipients can browse available food and can request the number of portions they need. They can also track the pickup location and show their QR code during the collection so that NGO can scan the QR code. Finally, the donation is completed and status updated are reflected for all users. In summary, beelyss support the full food donation workflow from posting, NGO verification and coordination to recipient collection with NGO verification and real-time tracking. That's all from us. Thank you.